Hello everyone, it's my pleasure to present our work MP-ReID, which introduced a new benchmark for multimodal multi-platform person re-identification task, and also provide a comprehensive dataset MP-ReID with an effective method uniprompt. Our motivation stems from observations and explorations within the field of person re-identification. Existing research in this area primarily bifurcates into two domains. Among these, cross-modal person re-ID represents a relatively mainstream direction, supported by datasets such as SWISE-WAY, which facilitate algorithmic investigation and address cross-modal re-ID challenges. However, this line of research exhibits a notable limitation. It predominantly considers data originating from the same acquisition platform, with minimal variations in viewpoint between images. In addition, in recent years, some research has focused on person re-identification with multi-platform acquisition, leading to the creation of valuable datasets, such as AG-ReID and its subsequent versions. The algorithms derived from these efforts have demonstrated improved capabilities in addressing the impacts and challenges posed by viewpoint variations and image rotations in person re-identification. However, these studies have not yet taken into account the modality attributes of the images. While current research in person re-identification hasn't adequately addressed such complex scenarios. As a result, methods designed in existing studies often fail to perform effectively in these challenging conditions. We introduced the MP-ReID dataset, which was collected meticulously compiled through the integration of diverse sensing modalities, 6 ground RGB cameras, 6 ground infrared cameras, an UAV RGB camera, and an UAV thermal camera. These captures are sourced from a variety of environments, including outdoor and indoor settings, as well as from UAV cameras for aerial perspectives. The MP-ReID dataset collected videos exceeded 13 hours, featuring 1,930 distinct identities and 136,156 human bounding boxes acquired from 14 cameras. This scale is comparable to that of multi-view traditional datasets, thus establishing our dataset as a substantial resource for ReID research, featuring numerous cameras and human annotations across various platforms and modalities. This dataset comprises 3 distinct modalities and 3 different scenes, with notable disparities between images captured in different modalities and scenes. Notably, the top row shows thermal infrared images acquired from UAVs, marking our inaugural integration of this specific modality, captured from this platform, into the domain of person re-identification. We showcase a range of variations to highlight the challenges present in person re-identification and MP-ReID dataset. Selected samples from different scenes and modalities illustrate the disparities between various viewpoints, instances of low resolution, cases of motion blur, and scenarios involving occlusion, respectively. To enable the model to effectively learn the semantic information from such multi-modal, multi-platform pedestrian data, we devised specialized text prompts and designed a multi-stage learning schedule, as illustrated in the figure. We first present the composition of our specifically designed text prompt. This prompt incorporates a global prompt for specified ReID, while a modality-aware prompt is employed to capture information from different modalities, and a similar design is adopted for various platforms. Specifically, in the early stage of training, the modality and platform-aware prompt parts mentioned previously are frozen. This allows the model to primarily learn the ID-specific prompt components, thereby extracting and capturing the unique semantic information associated with each identity. Subsequently, we freeze the previously learned ID-specific prompt and proceed to learn the platform and modality-related features for each identity. This process enables the prompt to adaptively capture characteristics across different modalities and platforms. Throughout this entire learning process, our visual enhancement network remains active, continues learning to extract features from the image data that are relevant to both modality and platform. During the preceding stages, the image encoder was kept frozen, focusing solely on learning the text prompt. Once the connections between the text and image features are established, we freeze the text templates and employ a conventional loss function to train the image encoder, which includes ID loss, triplet loss, and cross-entropy loss. This training aims to enable the image encoder to encode modality and platform-specific information into the features extracted from diverse images, thereby enhancing classification accuracy. To establish a comprehensive benchmark, we compared our uniprompt ReID method with several baseline approaches. We designed a total 12 different experimental settings, considering all for image sources, ground RGB, ground infrared, UAV RGB, and UAV thermal, to validate the various characteristics of our proposed MP-ReID. Here we show the quantitative results of total 12 experiments. The table clearly illustrates the strong accuracy of our uniprompt ReID method. To validate the efficacy and robustness of the proposed uniprompt ReID method, experiments were carried out on established public datasets for both multimodal and multi-platform person ReID. The multimodal evaluation utilized the SYSUM01 and RegDB datasets, while the multi-platform evaluation employed AG Re-ID. Furthermore, a comparative analysis was performed against current SOTA methodologies on these benchmarks. The outcomes reveal that our approach consistently reaches SOTA levels of accuracy across these datasets. This confirms that our method's utility extends beyond the complex cross-modality and cross-platform challenge presented by the MP Re-ID dataset, demonstrating its applicability and superior robustness across various person Re-ID tasks. Thank you for your attention.